Good morning, everyone. So we are now in our week 11 lesson, which is about mathematical induction. So in algebra, we are using algebra to prove or derive a certain formula. So geometry, we are also proving axioms or theorems. So diri naman sa mathematical induction, we are proving statements or equation that is involving natural numbers that are true for all natural numbers. So when you say natural numbers, these are counting numbers, for example, 1, 2, 3, 4, until positive infinity. So in our mathematical induction, we have there the principle of mathematical induction, which states that suppose that the following two conditions are satisfied with regard to statement about natural numbers. So ginabasa ko subong harana sa inyong module. So for the condition 1, the statement is true for the natural number 1. Next, for condition number 2, if the statement is true for some natural number k, it is also for the next natural number k plus 1. So si k, any natural number, and then si k plus 1, amo na siya ang next nga natural number sang aton nga k. Then, the statement is true for all natural numbers. Amo na siyang aton the principle of mathematical induction, which later on we will be using in proving some mathematical statement. Okay, so let's have here an example. Prove that 1 plus 2 plus 3 plus 4 plus up to a certain natural number n is equal to n times the quantity n plus 1 over 2 for all n is greater than or equal to 1. So, ano ni si n? So, si n is the set of natural number. And how about diri si n sa aton nga given sa statement? So, si n diri sa left side sa aton nga equation, amo ni siya ang formula kung paano nakuha ang pattern nga 1, 2, 3, 4. So, amo siyang formula. And then we are going to prove that n times the quantity n plus 1 over 2 is satisfy for all n is greater than or equal to 1. So first step you're gonna do is to verify n equals 1. So what if let's substitute that n is equal to 1. So amo siyang kagina sa aton nga principle of mathematical induction sa condition number 1 that the statement is true for the natural number 1. So, i-prove ta danay, so i-verify ta if it is or if it can satisfy our formula for n equals 1. So, let's substitute n equals 1. So, 1 equals, so tanan yung variable n, you change it into 1. So, we have now 1 times the quantity 1 plus 1 over 2. So, by simplifying, 1 plus 1, that is 2. And then 1 times 2 is 2. 2 divided by 2, that is 1. So therefore, 1 is equal to 1, which is correct. So, therefore, n equals 1 is true for this formula. Okay, now let's try. Okay, now let's proceed to our second step, which is the induction hypothesis. Assume that 1 plus 2 plus 3 plus 4 until a certain key natural number is equal to k times the quantity k plus 1 over 2 where n is equal to k is true. So, what we did here is we just only substitute n sa aton, we just substituted k sa aton variable nga n. So, tanan nga n, we change this into k. So, si k is any natural numbers. And then we need to prove that 1 plus 2 plus 3 plus 4 plus until k plus 1. So, si k plus 1, amo ni siya ang next nga term sang ato nga k is equal also to the quantity k plus 1 times the quantity k plus 1 plus 1 over 2. Where n equals k plus 1 is also true. So, we just only substitute k plus 1 to our variable n. Now, let's simplify. So, we have since aton nga mathematical induction, principle of mathematical induction, in the condition number 2, that if the statement is true for some natural number 1, it is if the statement is true for some natural number k, it is also true for the next natural number k plus 1. So which means, nga gin-assume tadi kagina sa first statement, this is already true since sa aton yung principle of mathematical induction. So we just use this equation to prove the k plus 1. So, kung ma-add ko both sides of the equation by k plus 1, and then ma-manipulate na lang ko din sa right side sa aton equal sign. So, we have here k times the quantity k plus 1 over 2 plus 2 times the quantity k plus 1 over 2. Since sa aton di nga first term, yara siya denominator, so dapat para sila denominator para makombine ta sila. So, we multiply or we find its LCD or the least common denominator. And then by simplifying, we have now k times k using the distributive property. We have k squared plus k times 1 that is k plus 2 times k that is 2k, 2 times 1 that is 2 over 2. And then by simplifying, we have now k squared plus 3k plus 2 over 2. So thus, the formula is true for n equals k plus 1 by principle of mathematical induction. The formula is true for n greater than or equal to 1. So if you simplify this one, so I want you to get your notebook there, paper, then you simplify this one. So kung mag-simplify ka mo, ma-equalan ni siya sa aton nga na prove. So, kung na-prove nyo na gani, therefore, the formula is true for n equals k plus 1. That is by principle of mathematical induction. So, i-simplify nyo lang ni sila kay ma-equal sila nga duwa. Next example is prove that 1 squared plus 2 squared plus 3 squared plus until n squared equals n times the quantity n plus 1 times the quantity 2n plus 1 over 6 for n is greater than or equal to 1. So, ang aton formula here is si n squared, ang formula sa aton nga pattern. So, that is n squared. So, ang i-prove ta is this for k plus 1 if it is true. So, first step is you need to verify this for n equals 1. Okay, so you just substitute 1 to our n variable. So, tanan di nga n makitaan. Tapos sa ating formula, you just substitute it by 1. So, we have now 1 squared equals 1 times the quantity 1 plus 1 times the quantity 2 times 1 plus 1. So, by simplifying, this becomes 2. 1 plus 1, that is 2. And then, 2 times 1, that is 2 plus 1, that is 3. So, 1 times 2 is 2 times 3 is 6. So, we have now 6 over 6, that is 1, and 1 squared, that is 1. So, 1 is equal to 1. So, na-prove ta na sa n equals 1. Now, let's proceed to our second step. So, kung sa first step na palang gani, we cannot prove that 1 is equal to 1, therefore, sala na aton nga formula. Next, by using the induction hypothesis, assume that 1 squared plus 2 squared plus 3 squared plus up to k squared is equal to k times the quantity k plus 1 times 2k plus 1 over 6 where n equals k is true. So, ginhimo talande, we just only substitute k to our n sa aton giginang formula. So, by the second condition sa aton nga principle of mathematical induction, which is making k true. Now, we need to prove that 1 squared plus 2 squared plus 3 squared up to the quantity k plus 1 squared equals, so we substitute k plus 1 to our n, which is, this becomes now the quantity k plus 1 times the quantity k plus 1 plus 1, 2 times the quantity k plus 1 plus 1 over 6, where n equals k plus 1 is also true. So, muna siya aton nga i-prove. So, if I want you to simplify this, on your paper. So, simplify nyo that. What's the result? Okay, now we have here 1 squared plus 2 squared plus 3 squared plus up to k squared equals the quantity k times the quantity k plus 1 times the quantity 2k plus 1 over 6. So, this is by the given second conditions ng aton nga principle of mathematical induction. Now, let's add both sides of the equation by the quantity k plus 1 squared. So, nag-add kita both sides. And then, let's simplify. So, this becomes, using the distributive property, k times k, that is k squared. Then, k times 1, that is k. And we have, you just copy 2k plus 1. So, for this one, you apply the factoring. So, we have now k times k, that is k squared. K times 1, that is k, times 2 is 2k. And 1 times 1 is k. Okay, since the first term kami our denominator na 6, we find its LCD. So, we have now k squared plus k times the quantity 2k plus 1 over 6 plus 6 times the quantity k squared plus 2k plus 1 over 6. So, we just combine this by simplifying since they have the same denominator. Pwede tanan na sila ma-combine. So, we have now k squared times 2k. So, we have 2k cubed. K squared plus times 1, that is k squared. K times 2k, that is 2k squared. K times 1, that is k. And then 6 times k squared, that is 6k squared. 6 times 2k, that is 12k. And 6 times 1, that is 6. And then combining all similar terms. So since isa laman di ang may cube na exponent, so we just copy 2k cube. And then tanan yung may squared. You just simplify. So, i-add. So, we have now 9k squared. And then, tanan niya may k, you add. So, we have now 13k. So, 12k plus k, that is 13k. Then, you copy the constant 6. Thus, the formula is true for n equals k plus 1 by principle of mathematical induction. The formula is true for n equals or greater than or equal to 1. So, kung din-simplify nyo to kaginang sa aton, we need to prove amo ni nga result ang inyo nga makuha. So, therefore, the formula is true for n equals k plus 1. Okay, so that's all. If you have questions, kindly message me to our group chat. That's all. Thank you for listening.